Now, ma'am, it's visible. Yes.
Okay, fine.
Over to you, ma'am.
Yeah, thank you. So, good morning, students. This is Dr. Garima Agarwal from Manipal University, Jaipur. Today, we are discussing our unit number 6, that is reduction formulas. In this lecture, we'll solve integration of a trigonometric function with the help of reduction formula. Also, we'll apply the concept of definite integral to find length, area, volume, and we'll find volume of surface through revolution, and beta and gamma functions are for improper integrals. Also, we'll discuss Euler's integral. So first of all, let's discuss the reduction formula. What is reduction formula and how we can use the integral to find how we can use the integral to find the integration of the function whose power is n. Let's say I need to find the integration of sine raised to nx, right? So by if we don't want to use the reduction formula, it will be complicated for us to find the integration of that kind of term, right? So how we can use reduction formula? First of all, we split this term sine raised to nx into sine raised to n minus 1x times sin x, right? Then sine raised to n minus 1x is the first function and sin x will be the second function, right? Then we'll use the concept isolate. First term as it is, integration of second term, that is minus cos x, minus integration differentiation of first term and integration of second term, right? Now we'll again integrate this step. We can write cos square as 1 minus sin square. Then we'll multiply sine raised to n minus 2 by 1 minus sin square, right? Then this middlemost term sine raised to n minus 2. Look, in is sine integration sine nx, sine raised to nx dx. So sine raised to n minus 2 can be written as in minus 2, and this term can be written as in, right? Then we'll shift this in the left hand side. This term is also in. So if we collect the coefficient of in and this 1 will cancel out, then we'll shift this n in the right hand side. So this is the integration of sine raised to nx by reduction formula. Clear? Similarly, we can find integration of 10 raised to nx. We'll split it into 10 raised to n minus 2x into 10 square x. Now we know that 1 plus 10 square is sec square. So 10 square can be written as sec square minus 1. So we substitute the value of 10 square as sec square x minus 1. Then we multiply 10 raised to n minus 2 in with sec square minus 1. We can write this first integration is I1 and the second integration is I2. To find the integration of first step, let 10x is equals to u. So sec square x dx will be du. This term will be du and it is u raised to n minus 2. Right? We can easily integrate this term u raised to n minus 2 and then we'll again substitute the value of u, that is 10x. Right? So this if I substitute the value of this integration, in will be integration of 10 raised to nx dx, and the value of this term will be value of this first integral is 10 raised to n minus 1x upon n minus 1 minus integration of this step, right? Clear? So this is the integration of 10 raised to nx. Similarly, we can find uh, integration of any trigonometric function by using this reduction formula. Clear? Here also we have integration of sine raised to mx cos raised to nx dx, where m and n are positive integers. If n is odd, the power m of the sin x can be arbitrary, then we'll substitute u equals to sin x, right? If n is odd, whatever the value of m is, whether it is even or odd, if n is odd, we'll substitute u equals to sin x. If m is odd, we'll substitute u equals to cos x. If both the powers are even, then first use the double angle formula, then we'll integrate it, right? What is double angle formula? This one is double angle formula, like sin 2x is 2 sin x cos x, um, cos cos 2x is cos square x minus sin square x, or 1 minus 2 sin square x, or 2 cos square x minus 1. So first we'll use this formula and then we'll integrate it. Right? For example, here see the power of sine is odd, so we'll substitute u equals to cos x, right? And the value of du is minus sin x dx. So we'll substitute both the values in the given integral. Sin square x cos square can be written as u square, and sin x dx can be written as du, right? So it will convert into this step. Then we can easily integrate u square, that is u cube by 3. Integration of u raised to 4 is u raised to 5 by 5, and integration of u raised to 6 is u raised to 7 by 7. Then we'll substitute the value of u, that is cos x. We'll add one arbitrary constant because it is indefinite integral, no limit is given. So we'll add one constant c. Now if we want to integrate this type of term like 10 raised to mx sec raised to nx dx, then what are the conditions? If n is even, we use the identity 1 plus 10 square is sec square, if the value of n is even. The second function is expressed as the tangent function, so the entire integral is expressed as the function of 10x, and then we can integrate it. If both the powers are odd, then the factor sec x 10x, which is necessary to transform the differential, is uh, separated. Then the entire integral is expressed through the sec x, right? If n is odd and m is even, then the tangent is expressed as the secant using this identity 1 plus 10 square is equals to sec square, right? For example, here we have this question, integration of 10 square x sec square x, right? Here the power of 10 is even and the power of sec is odd. So first of all, we'll convert 10 square into sec square x minus 1, then we'll multiply by sec cube x, right? Then by using the reduction formula, we can write the value of integration sec raised to 5x dx. This is the standard formula, right? So this the integral is integration of sec raised to 5x minus integration of sec cube x. Then we'll substitute the value of integration sec raised to 5x, and then we'll substitute the value of integration sec cube x. We can find these two integrals by the reduction formula, as we have find the value of integration sine raised to nx dx or 10 raised to nx dx. In the similar manner, we can find integration of sec raised to nx dx or sec raised to 5x dx, right? Now the next is integration of cot uh, raised to mx and cosec raised to nx, where m and n is positive integer. Now if n is even means the power of cosec x is even, we use the identity 1 plus cot square is cosec square. If both the powers are odd, then the factor cosec x cot x, which is the necessary to transform the uh, differential, is separated. If both the powers are odd, we'll separate cosec x cot x. If n is odd and m is even, then cot is expressed as the cosec by using this identity, right? If n is odd and n is even, we can use this identity, right? For example, I think the example is not there for this type of function, but we can easily integrate it, I guess. If you have any problem in these reduction formula, please raise your hand. No? Okay, fine. So the next is the application of integral calculus. We can use integral calculus to find the area under curve and arc length, right? So how we can find the area under curve? The area enclosed between given curve and x-axis, like this. Let's say we have this curve, so, and we need to find the area between this curve and the x-axis. This one is the x-axis, so this entire region can be included. And the second is area between two curves. Let's say I have these two curves, so I need to find the area. So this shaded part is the area. Now the question is how we can find the area, what are the limits, what are the formulas, that we'll discuss through example. These are the just a minute. I'm sorry. These are the formula to find the area under curve. The area bounded by the curve y equal to fx and axis between x equals to a and x equals to b. We can use this formula, integration a to b y dx or integration a to b fx dx, right? If r equals to f theta is the equation of the curve in polar coordinate, and theta 1 theta 2, where theta 1 is less than theta 2, are two radii vector enclosing the sector, then the area of the sector is 1 by 2 integration under the limit theta 1 to theta 2 r square d theta. The area below the axis is regarded as negative, right? If we consider the area, uh, let's say I have this circle here, and if I want to find the area of this circle, definitely it is negative. This axis is x-axis, so below this x-axis it will be negative. We need to find where the curve intersect and integrate. That I'll discuss in the question. The difference between two functions, okay, this also required in, let it be. Now here we have a curve y equals to x e raised to x between x equals to 0 to 1, right? We need to find the area. So what is the formula? x1 to x2 fx dx, right? So fx is x e raised to x, x1 to x2, that is 0 to 1 dx. We just need to integrate it, apply the limits, and we'll get the area under this curve. Clear? But in this question, limits are given. Now, in the next question, we need to find the area of the region enclosed by these two curves, x minus 2 and x square minus 4x plus 2. First of all, we need to find the point of intersection between these two curves. How we can find the point of intersection? We'll equate these two equations. X minus 2 is equals to x square minus 4x plus 2. We just equate these two equations and get the intersection point 4 and 1. Now the area between these curves, we have the point of intersection, that is 1 and 4. Right? So x1 to x2, fx1, that is the first curve, or fx minus gx dx. You can consider any function as fx and any function as gx, right? If I substitute the value of fx and gx and integrate it under the limit 0 to 1, I'll get the area 27 by 6, right? If you do this process in the reverse order, let's say I consider x square minus 4x plus 2 as fx and x minus 2 is gx, right? I'll get the same area, but it will be minus 27 by 6. But area cannot be represented as negative, right? So it will be 27 by 6 only. Here. Find the area of the region bounded by the parabola and the line through the points 1, 4 and minus 3, minus 4 on the parabola. Right. So the equation of the line is y2 minus y1 upon x2 minus x1. This is the equation of the slope. So the equation of the line will be y minus 4 is equals to slope 2 x minus 1. That will be the equation of the line. This one is the line. And the equation of the parabola is y equals to 5 minus x square. So this is our parabola. Now the intersection points are, these are two intersection points. These are two intersection points, right? And the coordinates are 1, 4, minus 3, minus 4. These are two intersection points, right? Then I need to find the area between these curves. So it will be again the first curve minus the second curve, right? So it is fx minus gx. You can consider again any curve as fx and any curve as gx, and the limit of x. By this figure you can see that the limit of x here in this intersection point, the coordinate of x is minus 3, and in that intersection point the coordinate of x is 1. That means the limit will be minus 3 to 1, right? And after integration we'll get 32 by 3. Now the next is arc length. Let's say we have a curve y equals to fx and p, and okay, before moving towards the arc length, let me take your question first. If you guys are having any doubt in area under curve, please raise your hand. Yes, Rakshit, you can unmute yourself and ask your question.
Hi, ma'am. Good
Hi.
afternoon. I'm audible, na?
Yeah, you are.
Ma'am, can you tell again, like, how you are finding the x and y value? Like limit.
You mean to say this point?
Yes, yes.
This point is given already, first thing.
Okay.
But
And
at the same time, time I can find these values. I'll explain it. You first finish your question. I'll explain it.
the limit, the value which you have used in limit, I'm asking about that one.
Yeah, minus 3 to 1.
Yes, yes, yes.
We are integrating with respect to which variable?
X.
That means we need to put here the limit of x, right? Now go
Okay.
to our diagram. What is the limit? What is the value of x in this coordinate?
-3, -4.
And what is the value of x in this coordinate?
1.
1. That means the limit should be -3 to 1.
1. Okay.
If we want to put the limit of x, it should be -3 to 1. If in case I want to put the limit of y, it should be -4 to 4,
4. Okay.
right? Now the
In
thing is, yeah,
previous question you have find or you use.
in the previous question I find out the limit of x by equating these two curves.
Okay, ma'am.
Okay, let me explain it here again, no worries. Like in this question I have only two equations, I don't have any intersection point, right?
Okay.
And to integrate I need to find the intersection point. How I can find it? I just equate both the equations, that is x minus 2 is equals to x square minus 4x plus 2, right? And after simplification I'll get this quadratic equation, and if I get the root I'll get 4 and 1, two values of x, that is 4 and 1,
1.
right? So these are the intersection point of these two curves.
Okay.
Clear?
Okay, ma'am.
Then
Yes, yes. Got it.
then I apply this formula, that is you can consider any function as fx minus any function, any other equation of the curve as gx. So fx minus gx integration dx, and the limit of x will be 1 to
1 to 4.
4, right? You can take it in the reverse order as well, this term as fx and this term as gx, right?
Okay. Okay.
This concept is clear.
Okay. Yes, ma'am.
Now consider
Thank you.
this question also.
Okay.
Here I have the equation of parabola. I have 2 points, uh, a parabola, and the line through the point this on the parabola. Like, right? What is the question? Question is, you have this parabola, right? You have 2 points on this parabola, -3, -4. Definitely it will be somewhere in third quadrant, and 1, 4 definitely somewhere in first quadrant, right? This one is clear.
Yes, ma'am.
So definitely this will be our line.
Right.
Clear? And this the region bounded between these two curves, this one is the region, right? Now I need to find the area. What I'll do, again fx minus gx dx, and the limit of x will be -3 to 1.
Okay, ma'am.
Now substitute fx and gx as 5 minus x square and 2x plus 2. And -3 to 1. Clear?
Okay, ma'am.
Any other query? Yes, Mr. Datta, you can unmute yourself.
Hello, am I audible?
Yes, you are audible.
Okay, it's not directly to this lesson, but you see, when we submitted our practical, our assignments, we did it in Word, and in Word it was possible to do the equations, but it took a lot of time to, to type those equations. So what have you thought about in the real exam, when we are going to have it in exam? How are we going to write those equations on the keyboard? Have you given a thought to that? I mean, say, because it was definitely, I am sure all the others will also agree with me, it was taking a lot of time to put it in the Word format, the equations.
Okay, I'll discuss it to the management. I agree that it's bit time consuming, but
Yes.
right now I'm not able to answer this question. I'll first discuss to the management and then let you know what about the end of
Right.
exam.
I mean to say, then probably you can have a
Yeah, I got your
simulated.
point.
Yeah.
Now let's move towards the next topic. if we don't have any query on area under curve? Fine. So the next is arc length. Let's say this one is our arc. Arc, you know what is arc? A part of any curve. Let's say I have a circle, right? If I consider only this part, that will be arc, right? So let's say this is arc. P and Q are 2 points on the arc. To find the arc length S on the curve, divide the curve into pieces. Then the length of one piece is ds, which is the abscissa for the right angle triangle whose sides are dx and dy. Yeah, all students are requested, please mute. So the total length of the curve is the study of the sum of the small length ds. Therefore, it is integration dx, right? And ds square is x square plus 3y. For example, I need to find the arc length of y equal to x cube between the point -1 and 2. So we need to find the arc length of y equals to x cube between these 2 points, right? Now we know that the value of ds is root dx square plus dy square, where y is x cube. So the value of dy is 3x square dx. If we substitute the value of dy, it will be 3x square dx whole square. And if I take dx square common, it will convert into this term. So this is the value of ds. This is the formula of arc length, integration ds. Now the value of ds is 1 plus 9x raised to 4 or 3x whole square dx. That means this dx means I need to write the limit of x, right? So the limit of x is -1 to 2. -1 to 2. Now just integrate this term, apply the limit, add up arbitrary constant. Actually this constant is not required because now we are doing the definite integral. So there is typo error. This constant is not required. This is the arc length of the curve y equal to x cube under the point -1, 1 and 2, 8. Right? Again, if this time our curve is given in the parametric form, like x is equals to a cos t plus t sin t and y is equals to a sin t plus t cos t. This is the parametric equation and we need to find the arc length, that is integration root dx by dt whole square plus dy by dt whole square. This is the formula formula of arc length if the equation is in parametric form. Clear? So if it is in Cartesian form, the arc length is formula for arc length is integration ds. If the equation is in parametric form, the arc length will be dx by dt that should be dt. Again there is typo error, right? So we substitute the value of dx by dt and dy by dt, and the limit will be 0 to t. Measure from t equals to 0 to any point on the curve. So I'll take any point means t, 0 to t. After integration I'll get the required length, right? Am I clear? How we can find the arc length? Any question? Now the next point is surface of revolution. The first is solid of revolution and the second is surface of revolution. Solid of revolution, if a plane area is revolved about a fixed line, then the body what is generated by the revolution of the plane area is called solid of revolution. And surface of revolution, if a plane curve is revolved about the fixed line, then the surface which is generated is known as surface of revolution, right? Now these are the formula. If the x-axis of rotation, if the axis of rotation is x-axis, then the area bounded by the curve in between the ordinate x equals to a and x equals to b and x-axis revolved about the x-axis, then the volume will be pi y square dx, right? If the curve revolve about x-axis, then the formula will be pi y square dx. If the curve revolve about y-axis, then the formula will be pi x square dy, right? In this case, we need to put the limit of x, and in the second case, we need to put the limit of y. Then if the curve is in parametric form and revolve about x-axis, then the volume will be pi y square dx by dt times dt. And if it is revolved about y-axis, then the formula will be pi x square dy by dt times dt. Clear? This is the formula to find surface of revolution, that is about, if it is revolve about x-axis, it is 2 pi y ds. If revolve about y-axis, it is 2 pi x dx. S is the length of the arc measured from x equals to a to any point. Now for example, we need to find the volume of the solid generated by the revolution of this curve about x-axis. So revolve about x-axis, that means it is pi y square dx. Formula is integration pi y square dx, a to b. Now the thing is, we need to put the value of a and b. So this is our curve, y equals to a cube upon a square plus x square. Now it is revolving about x-axis, right? This is our x-axis. This whole axis is known as x-axis. Clear? So what will be the limit of x? Any idea? What will be the limit of x? Minus infinity to infinity, right? If I took 0 to infinity, that means we need to multiply the entire integral by 2, right? 2 times 0 to infinity or minus infinity to infinity. Both the terms are same, right? Then we substitute the value of y square. that is a raised to 6 upon a square plus x square whole square. Then let x is equals to a tan theta and the value of dx will be a sec square theta d theta. We just substitute the value of x and dx, right? And then simply integrate it under this limit. So this is the volume of the solid generated by revolving about x-axis. Clear? Now we need to find the volume of the solid formed by revolving the cycloid. This is the standard equation of cycloid along x-axis. The first part is along x-axis. That means, okay, one more thing, the equation is in parametric form. X is a function of theta, y is function of theta. And along x-axis, that means integration 2 pi y square dx by d theta into d theta a to b. So we have value of y square, we can find dx by d theta. We need to find only the limit of theta, right? If we draw this cycloid, we can see that this curve lies between this x-axis and this y-axis. The curve lies between these 2 points, right? Here theta is 0. Theta is 0 and theta 2 pi. So here theta is 0, here theta is pi by 2. If I take the entire circle, we'll get again here that is theta is equals to 2 pi. So this curve lies between theta is 0 to 2 pi. So instead of taking limit 0 to 2 pi, I took limit 0 to pi and multiply it by 2, right? Then we substitute the value of y square, then we substitute the value of dx by d theta and integrate it, right? The next question is find the surface of a sphere of radius a. So this is the equation of a sphere. ds by dx will be a by y. Now this is our formula to find the surface 2 pi y ds. The value of ds will be, that is, ds is arc, s is arc. So the limit will be minus a to a, right? Because the radius of this sphere is a, right? So it is minus a to a. We just substitute the value of ds by dx a by y and integrate it under the limit minus a to a, that is 4 pi a square, which is the standard surface of any sphere. Clear? The next is beta and gamma function. So if you have any query in volume, surface, integral, volume through revolution, please let me know. No? Fine. So our next topic is beta and gamma function. First thing is beta and gamma function is improper integral and it is also known as Eulerian integral. Beta and gamma function generalize the factorial of non-integer values. What is the definition of beta and gamma function? First of all, this is the notation for beta function, beta mn. and the value is integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. Right, this is beta function, and gamma, this notation is known as gamma. So gamma n, pronounced as gamma n, is 0 to infinity e raised to minus x x raised to n minus 1 dx. So these are the formula for beta and gamma functions. Now we have few properties like beta mn is equals to beta nm. For example, if I write beta 2 3, it will be 0 to 1 x raised to 2 minus 1 1 minus x raised to 3 minus 1 dx. And if I write 3 2, it will be 0 to 1 x raised to 3 minus 1 1 minus x raised to 2 minus 1 dx. If I integrate both the terms, I'll get the same value, right? That means beta mn is equals to beta nm. Here we have proof. This is the formula. If we replace x by minus 1 minus x, if I replace x by 1 minus x, it will be converted into x. So beta mn is equals to beta nm. Now gamma n is n minus 1 gamma n minus 1. Gamma n is 0 to infinity e raised to minus x x raised to n minus 1 dx. This is the formula. Then we integrate it by using Eilert formula, first and second. First as it is, second integration, minus integration, first differentiation, second integration. Then we apply the limits. E raised to minus infinity is 0. So when we apply this upper limit, it will convert into 0, right? And this integral is here. And again, this is the value of, look, gamma n is 0 to infinity e raised to minus x x raised to n minus 1 dx. So gamma n minus 1 is 0 to infinity e raised to minus x x raised to n minus 1 minus 1 dx. If it is n, here we have n. If it is n minus 1, here we have n minus 1. That is n minus 2. N minus 2. So we can write this integral as gamma n minus 1. Clear? So beta mn can be written as gamma m minus 1 gamma n minus 1 upon gamma m plus n minus 1. Now transformation of gamma function, gamma n upon lambda raised to n, these are standard formulas, is equals to integration 0 to infinity e raised to minus lambda y raised to n minus 1 dy. This is also one more formula, integration 0 to infinity e raised to minus x by n dx dz, that is n gamma n or gamma n plus 1, and gamma n can be also written as 0 to 1 log 1 by t whole power n minus 1 dx. Now transformation of beta functions, these are the formula to transform the beta functions. Relation between beta and gamma function, this is one of the most important relation. And also we have few deductions. Gamma n, gamma 1 minus n is pi upon sine n pi. Gamma 1 plus n, gamma 1 minus n is n pi sine n pi. Integration 0 to pi by 2 sine raised to m theta cos raised to n theta d theta is gamma m plus 1 by 2 gamma n plus 1 by 2 upon 2 gamma m plus n plus 2 by 2. Gamma m plus half is root pi upon 2 raised to 2m minus 1 gamma 2. This is also known as duplication formula. Now we have few questions or examples. Gamma half is root pi. This is one of the most important result in beta gamma function. Gamma half is root pi. How we can deduct it? We know that gamma n, gamma 1 minus n is pi upon sine n pi. If we substitute n is equals to half, the first term will be gamma half, second term is again gamma half, and the right hand side pi upon sine pi by 2. Sin pi by 2 is 1. So gamma half square is pi and gamma half is root pi. Then we need to compute gamma minus half. So we'll substitute n is equals to minus half. It will be sine minus pi by 2, that is minus 1. So the right hand side will be minus pi. Gamma 3 by 2 can be written as 1 by 2 gamma half. See, gamma n is n gamma n minus 1. So gamma 3 by 2 n minus 1 gamma n minus 1. So 3 by 2 will be 1 by 2 gamma 1 by 2. Right? So 3 by 2 can be written as 1 by 2 gamma 1 by 2. Clear? So gamma of minus half is minus 2 pi upon root pi or minus 2 root pi. Now in the next example we need to prove that integration 0 to infinity e raised to minus t dt, that should be t, is root pi by 2. Now we know that gamma n is 0 to infinity e raised to minus t raised to n minus dt. This is the formula of a gamma function. If I substitute t equals to x square, the right hand side will be e raised to minus x square whole power n minus 1, and the dt will be 2x dx. So 2x dx, right? If I substitute now n is equals to half, I'll get if I substitute n is equals to half, I'll get integration e raised to minus x square, right? And gamma half is, if I substitute n is equals to half, gamma half is root pi. The right hand side will be 2 integration e raised to minus x square, and this term will be 1, right? So the value of this integral is root pi by 2, that we need to prove. Here we need to prove this conclusion: beta mn is beta m plus 1 n plus beta m n plus 1. Beta m plus 1 n is, as we know, beta mn can be written as gamma m gamma n upon gamma m plus n, right? So it will be gamma m plus 1 gamma n and addition of these two terms in the denominator along with gamma sign, right? Gamma m plus n plus 1 can be written as m plus n gamma m plus n. So this denominator can be written as m plus n gamma m plus n. Similarly, this can be written as, if I take gamma m gamma n upon gamma m plus n common, I'll get this term, right? If I take LCM in this bracket, I'll get the right hand, I can reduce the right hand side in the form of beta m n. Now if I need to integrate this term, right, what I'll do, first of all, I'll substitute x is equal x raised to 4 as y. So the value of dx is dy by 4x cube, right? So just substitute the value of dx, that is integration dy by 4x cube and 1 plus y. Now also I need to change this x into y. X raised to 4 is y. X is 4 raised to 1 by y raised to 1 by 4, and x cube will be y raised to 3 by 4. So it is dy 1 by 4 y raised to 3 by 4 1 plus y, right? Then I'll write it as y raised to minus 3 by 4 1 plus y. Then we can write it as, in this form, x raised to n minus 1 upon 1 plus x dx, that is pi upon sin pi. So this term will be pi upon sin pi times 1 by 4. Sin 1 by 4 is, sin pi by 4 is 1 by root 2. Right? So through beta gamma function we can easily find the integration. In this lecture we learn the reduction formula for trigonometric function, then we learn how to find the area between two curves and between curve and axis. Then we learn the arc length, volume of a solid through revolution and volume of. So can we conclude this session?
Okay,
Now,
ma'am.
now only one unit is left, but that unit is bit lengthy, so I need 2 more lectures to complete the syllabus, right?
Okay, ma'am.
Okay, thank you.
Thank you, everyone. Have a nice day.